In the last few lectures, we had met several of Python's important data types. We had met the integers, the floats, and then we had gone on to meet strings, lists, tuples, and even in passing met something called an iterator object. The range function was an example, at least in Python 3, although that's an advanced topic which we will discuss later in detail. But most of the usual data types that Python uses have been covered. One kind of data type, which is actually quite important, has not yet been touched upon, and that is called the dictionary. In this lecture, we are going to meet the dictionary. We are going to take a look at few of its important methods and uses, and we will try to make one non-trivial use of dictionary. But in this process, we will also make use of other things we have learned so far about lists and strings. And maybe we will also meet a few new things about lists and strings in the process. So let us start first with what exactly is a dictionary. Now all of you know what a dictionary is. You have, I'm sure, one or more on your bookshelves. And if you open up an ordinary dictionary, what you will see is that it has pages of writing. But what exactly is there? There is a word and its meaning. That's exactly what a dictionary is. To generalize this a bit, you have something which you can call a word, or the technical term is a key or keyword. So you have a key and you have its value. So a physical dictionary has keywords and their values. Values are the meanings. Our Python dictionary is very similar. It has keys and values. So how do you write a Python dictionary? Well, the first thing you learn about a dictionary is use a kind of bracket for it. A different bracket from the ones you have used so far. Remember, you used square brackets to delimit a list. Whatever you write inside square brackets with commas becomes a list. Whatever you write inside round brackets with commas becomes a tuple. Whatever you write within quotes becomes a string. So square brackets, round brackets are gone. The other bracket that's left is a curly bracket, or this is what we call the second bracket often. So dictionary is actually written within second brackets. In fact, this is the simplest possible dictionary. This is just an empty dictionary, something which has nothing in it. But it's still a dictionary. If you tried to find out its type, it will say it belongs to class Dict. Dict, of course, is short for dictionary. So this is, of course, fine, but this has nothing in it, so it's not really very useful. So let's try to see a more, better endowed dictionary, something which has more stuff in it. So what you need in a dictionary, as I said, is a key and a value. Or actually not one key and a value, but a bunch of key value pairs. So you could have something like this. A key, let's say A, or let's say apple, why not? So this is a string, of course, you are writing it within quotes, and let's say, just like in a dictionary, you would write its meaning. Of course, I'm not writing down exactly what the dictionary meaning of apple is. I'm just trying to give you an idea what this is. So here you have the key, which is apple. Here it is a string, and a value, in this case a fruit, again a string, and you separate the two with a colon. So key value pairs are written with key first, then a colon, then a value. But that's just one key value pair. You can have others, and this is basically how you do it. Of course, you have to start with a single quote, then write zebra, let's say. That's another key. An animal. Comma. Quote. Eagle. Colon. Key value. A bird. So this is our very rudimentary dictionary, which has 3 key value pairs. Keys are apple, zebra, and eagle. Values are a fruit, an animal, a bird, respectively. And you can easily see the several of the methods or functions that we had learned before can also be used for dictionaries. For example, I can look for the length of the dictionary using the len function. It says 3 because there are precisely 3 items inside my dictionary. Remember, each key value pair counts as one item. Okay. If you want to know what a particular key stands for, you can access it just like you would access a string or a list using square brackets. But for a list or a string, you would have to use a numerical index to access a particular item. So counting, of course, there starts from 0. So if D were a list, D square bracket 0 would mean the 0th, or in ordinary parlance, the first element, and so on. Here, of course, there is no such thing. You cannot say D0. If you tried, it's waiting for a long time because something has gone wrong. It's trying to figure out exactly what has gone wrong. It's saying key error. Why is it saying key error? It tried to look through the dictionary to find the key 0. It did not find it because remember, our keys were apple, zebra, and eagle. Okay. Since it could not find the key 0, it returned what is an error. It raised an exception. That's a technical term. And the error it raised was key error. Remember this. This is going to be useful soon. Or at least in the later part of this video. If you're trying to look inside a dictionary for a key which is not there, it's going to give rise to a key error. What you can do, of course, is look for the keys that are there. So here, unlike in a list or a string, you're indexing a dictionary, but you're not indexing them using numerical index values. You're using them using the keys. So if you ask D square bracket apple within quotes, that key does exist, and you get a fruit. So a dictionary can be accessed rather like a list or a string, but with keys and not with numerical indices. Can you change a dictionary once you've created it? Actually, you can. You can add new entries to a dictionary simply by assigning new values. This is again where this differs from a string in the sense that a string cannot be changed once you create it. So it's immutable. And it also differs from a list, which is not immutable, which can be changed. But for a list, you can only change indices or index values which the list already has. Change items at index values which the list already has. You try using an index which is not in the list as yet, you are going to get a list index out of range error. Here on the other hand, frog, for example, is not a key which is inside my dictionary, but I can create a new element. Dfrog equal to an amphibian, let's say. Once I enter this, notice Python did not talk back to me. That means that there was no error here. And what has happened to D? It has now added one more element. Apple, zebra, eagle were already keys. Now you have a key, frog. So a dictionary is mutable. You can change it. You can put in new keyword pairs in it. no problem. If you try to access a key which is not there, it's going to give you a key error. But if you want to create a new element using a key that is not there, you can simply do it by just assigning a value to that element in the dictionary. That as yet inexistent element in the dictionary. By the way, you can also change an element that's already there. For example, you could actually say decode zebra equal to an African animal. And now your dictionary has changed. The value assigned to the keyword zebra has changed. So you can create a new key value pair if it was not there before. You can also change it. Right. So, but how do you know what keys the dictionary already has? Here, of course, you can just take a look. You created the dictionary, so you know what keys it has. And the dictionary is small enough. You can just list it out and you can read off the keys. But there is a nice method which dictionary comes with called d.keys. It's a method, so to call it, when you call it, you have to call it with brown brackets. And what it gives you is that it tells you these are the keys in the dictionary. What about values? Well, that's also pretty straightforward. A fruit, an African animal, a bird, an amphibian. So you get both the keys and the values by using d.keys and d.values, these functions. And you get them, as you can notice, in an order which is the order in which you entered the thing here. Doesn't have to be, by the way. There are certain situations where the order can even be changed. But at least the association between the key and the value, that order is being maintained. The 0th element here is apple. The 0th element for values is a fruit, and so on. Can you get them both at the same time? Actually, you can. These are items, and there is a dictionary method called items, which returns this. It's a special class of object called Dict Items. So this is actually in Python 3. In Python 2, it would just return a list. But basically, you can think of it for the time being as if it's a list. It's a list, but the elements of the list are actually tuples. Tuples with apple, a fruit, zebra, an African animal. So keys, values put in a tuple. Okay. Now there are other dictionary methods, of course, and as I've already indicated in the previous videos, if you want to know more about methods for a particular class of object, all you have to do is ask for help. So ask for help for a dictionary. That's a class Dict. So once again, you have lots and lots of these double underscore things which, as we said, are important, but we are going to take a look at them a lot later. The ones for general use are here. Clear. Well, it removes all items from a dictionary. That's sort of easy to understand. Copy. It produces a shallow copy of a dictionary. We have met copy before for lists also. I did not talk about copy then, and I am not going to talk about the copy now. Once we learn a bit more about how Python manages a computer's memory, that is a slightly more advanced topic, but we will come to that later. We will talk about this copy for both dictionary and lists. Now get. Okay. Get is where things become interesting. But let me return to that a bit later. Let me just show you what are there. Items we have already met. A set-like object providing a view of these items. Okay, it's a set-like object, which is what this dict underscore items in front was really telling you. But, and remember, in a set, the order has no meaning. If you remember your mathematical definition of a set, 1, 3, 2, a set with these elements is the same as a set with 1, 2, 3. So here the set-like object here reminds you that the order in which the items are given does not really have a meaning. Of course, within each item you have the key first, value next. That of course has a precise meaning. But the order in which these items are returned is sort of random. Then you have keys, again another set-like object. Pop, something which should remind you of a list, and it sort of behaves the same way. You call pop with the key value as an argument, not an index position. Of course, that's what you have to do for a dictionary as opposed to a list. And it will remove the specified key and returns the corresponding value. Just like for a list, if you said L square bracket 3, it would remove the element at index 3, return it to you, but the new list will change. Here, pop does the same thing for a dictionary. It removes that particular key and returns the corresponding value to you. Now, it also says something. If key is not found, D is returned if given. So that is, you have the option of giving an optional argument here. That's an argument in square brackets. That's an optional argument. You can give D if you want to. Then small d will be returned. So you can actually say that if the key is not there, something is going to be returned. Okay, let me go back to the get that we sort of skipped over a while ago. Notice it says get, of course, self is something I've already met before. It's nothing but the dictionary itself. So the argument you really have to give is a key. So you're trying to get the value for key from the dictionary. So it's very much like using D square bracket with key in it. The difference here is this. Return the value for key if key is in the dictionary, else return default, which by default is the second argument. Remember, you cannot call it by the name default. It has to be the second argument. These arguments are positional. This is something we discussed in the last video. Slash in the name here. This is from Python 3.8 onwards. Slash here indicates that every argument which comes before the slash is positional. They cannot be referred to by their names. They have to be referred to by the position in which they occur. Self is there anyway for every object method. So d.get, D is self. You have to give key first, and default has a default value of none. So you don't really have to give it, but if you do give it, it has to be in the second position. The important thing is, as opposed to the indexing, is if you try to index with a key which is not there, you are going to get a key error. Here, on the other hand, if you try to try to get from the directory, from the dictionary, the value for a particular key, if it is not there, is going to return either none, which is the default value, or whatever default you have specified. This is going to be very important for us soon. Okay. Pop, we have already seen. Then there's pop item, which is similar. It pops, it removes the thing, but it returns not just the value, but the whole item. And the set default update values we have already seen. We don't really have to go through all the methods right now. But the one method that we need to really look at is get, because we are going to use that soon. Remember, we tried D0 and got an error. Yeah, key error, because this key is not there in the dictionary. But let's say if I try D.get 0, what do I get? Well, I get nothing. I don't get an error. I don't get a talkback either. But if you remember, the help said it returns the default. So why doesn't it show me anything? Because the default, by default, if you don't give it, is none. So what you can do is something like this. What this says is, From the dictionary, if the key is there, return the value. If not, return 5. And here the key is not there, so I'm getting 5. But if I do the same thing with the key which is there, what I get is the fruit, the value of the key. So this behavior of get, that it does not raise an error, but returns either none or something which you have asked it to return, is going to be pretty useful for us soon. Okay, so now that we have taken a look at what a dictionary is and what you can do with it, let us go to work trying to use this for some rather interesting usage. So this is a real life kind of application that I am talking about. Just knowing about dictionaries will not be enough for that, but it will come close. You will need to know a bit more of things most of which you already know, but maybe you will have to meet a few new things about strings and lists on the way. So let's take a look at this application I have in mind. And this is a pretty useful application. Let's say I have some text in a file, and what I want to do is I want to find out how many times each word has been used in that text. Okay, so first let's get the text. Now my text is in a file, and Python has very powerful file reading and file handling methods. But that's for a later video. For the time being, what I'm going to do is I'm going to cheat a bit. What I'm going to do is I will take a look at this page from a book I was reading a while ago. Maybe say this page. I definitely recommend you try reading this book. The Body, a Guide for Occupants. Okay, let me just rephrase that. I don't yet recommend that you read the book for the simple reason that I have not finished reading it myself. So I can't really tell you how great this is. It does seem to be quite good. And my experiences with earlier works of this author tells me that this is going to be a treat. This is a book by Bill Bryson. So if you have not read any of Bill Bryson's works yet, I definitely recommend reading them. In particular, A Short History of Nearly Everything. That's a fascinating book on science written by somebody who is a non-scientist. One of the best such books I've read in my life. But coming back to the task at hand, what I want to do is, instead of trying to read in a Mobi file using Python, which by the way can be done, I'm going to just copy the contents of this page, just this page, with this actually 3 pages together, but anyway, it comes out as one to me just by copying using Ctrl C, and I'm going to paste the whole thing inside a string in my Python interpreter. But there's a problem with that. The problem simply is that this string, which I'm going to call S, and I'm going to assign the value to it by using the equal to, the assignment sign. This much is so far so good. But putting multiple lines with line breaks, which this file definitely has, into a string would raise an error, because the moment you get a line break, it's like hitting the enter key. So Python thinks that you have ended, and then you would end up with a problem because you're trying to write something else after that. The way out of that is a third kind of string delimiter which we have not talked about. We have talked about a single quote and a double quote. The one we have not talked about yet is a triple quote. You can actually use a triple quote to delimit the string. Of course, a triple quote at the beginning, triple quote at the end. The great thing about triple quoted strings is that it allows you to have multi-line strings, and it preserves those lines as they are. So I'm going to paste this whole thing inside my terminal. Well, how do you paste it? I could either right click on the terminal and choose the paste option, or in my terminal I have to use Shift Ctrl V for that. Of course, in your own terminal it may be something else. But now the whole thing has come in, and Notice that although it does have a lot of double quoted things inside, bladder, feather and so on, that's not a problem because I've started the string with a triple quote. I'm going to end it with a triple quote. And that's the string done. So this string as a whole has been given to Python. Okay. So now I have this set of pages. Now, what you want to do with this is that you want to split this up into words and then count how many times each word occurs. So that's two different tasks. So first let's look at splitting up a string. And although we have not met this before, you should have guessed that there is a method for splitting up a string. And it's actually called split. So what does it do? Okay, that's easy to figure out. Look at help for s.split. It says split two arguments, sep equal to none, max split equal to -1. There are two arguments, sep and max split. Both of them have default values. So in fact you can call split without any arguments. Okay. Returns a list of the words in the string. So it's actually using the language that we have used right now. But when we said word, we meant literal words. In an arbitrary string, what does word mean? Well, using sep as the delimiter string, whatever sep is given is going to tell you what the delimiter is. Not the string delimiter, but the delimiter for the words. How do you know where a word begins and ends? You use sep. So here it says that in detail. Sep is a delimiter according to which to split the string. You are splitting it into words, but how do you know that words are distinct? You look for whatever delimiter you have specified in sep. None, the default value, this is the important one for us, means split according to any white space. So split in using spaces, tabs, new lines, characters which don't get printed on your screen when you try printing them. They are called the white space characters, and you are splitting according to white spaces. And discard empty strings from the result. So if you have, say, 3 spaces next to each other and you split with spaces, then there are empty strings in between the 2 spaces and you are discarding them from your final thing. Remember, what it returns is a list object where each of the words are separately there. And max split says maximum number of space to do, how many times to use this split. -1, which is the default value, means no limit. You split as many times as you can. So let's see this in action for our string. So S, that's a string. Let's try splitting it. And let's do it with the default values. Default values means the word delimiters are nothing but blank white spaces. And max split is -1, which means you will split as many times as you can. And notice what has happened. All these individual words that you had, sound, so, that, softer, a, this, old, English, with, even the th here is a word. It was a word in the original file. Just look at this softer th sound. So Python, of course, does not know the meaning of any of these words. It doesn't care. It's just splitting it up into pieces because the separation was with spaces. Now, there are some hiccups here. For example, I did not tell it to split also using the brackets. So it picked open bracket 80 as one element. At least not none yet found. So you have another with a closed bracket as a single word. So this is just rudimentary. You could also improve on these things further. But for the time being, let us just count how many times a given word occurs in this particular list. So I've taken the string S, which I just found by copy pasting inside a triple quoted string. Now I split it into words and I want to count every word. Now how do I count them? Of course, you can count things by doing something like this. We learned this before. Say L dot count. Wait, is there an L? No, there is no L. I forgot to actually save this splitted string into a list. It was just returned to me on the screen. So what I will do is I will now first assign it to a list L. So L, of course, is this list now. Now I could, of course, do something like L dot count. Look for a particular element, let's say by. How many times does the element quote by, that is the string by, occur in L? It says 12 times. So there's quite a lot of uses here. But notice that to do this, what you will have to do is you will have to take a look at each and every element as it occurs and count them. That can be done, of course. That's pretty easy to do in a loop. For example, you could say something like for x in L, just this. But the problem is here, by will be encountered 12 times and it's going to say by 12, it's going to say 12 every time. So let's say if I just said print x comma L dot count x, so I'm getting 6 2 here, I must have got another 6 2 elsewhere and so on. This will work sort of, but not very well. So notice that here it says in is there 33 times. So that means in this whole bunch of stuff that it has printed out, in 33 has actually occurred 33 times because 33 times x had the value in, quote in, and each time it was printed. So not a very efficient method, as you would agree. So can we do better? The answer is yes, we can. And that's where dictionary comes in. I'm not saying that this is the only way to do this. I'm showing you this way of counting the number of times each word occurs in a string simply in order to illustrate what you can do with dictionaries. But let's see. We will start here with a dictionary, which I'm again going to call D, but an empty dictionary, nothing in it yet. And then what I'm going to do, this is my first attempt. It may or may not work, but let's see. What I'm going to do is something like this. For x in L, so let's go run over the entire list again. Take the words each time. But then, what I will do is something like this. What does plus equal to 1 mean here? When you say something like a plus equal to 1, that's really shorthand for a equal to a plus 1. Programmers are lazy people, so they sometimes use shortcuts for things that they have to do over and over again. So this really means d square bracket x equals d square bracket x plus 1. So what does it say? Every time you meet x, you add 1 to the value. D square bracket x, of course, returns the value. You add 1 to it and store the result in d square bracket x. Simple, you're just counting. Every time you see an x, you add 1 to its count. End of story. Will this work? Unfortunately, no. You see, what happened was the very first element in L, that is the first x, was this, the. And what happened when I ran the loop was, once the body of the loop was entered, what was attempted? You attempted this d quote, the quote. So d the equals d the plus 1. Now D the does not exist yet. D, remember, is an empty string. It's still empty, as you can check. So because it's an empty string, there's no problem trying to assign D the a value. The only problem is, what are you trying to assign to it? You are trying to assign to it D the plus 1. And that actually is a problem, because D the plus 1 is an error, key error. Why? Because the key the does not exist in the dictionary as yet. So trying to get the value of D the will raise a key error. But we have already seen how to avoid that, right? Instead of using indexing, what we will do is something like this. I'm going to use the get method, and the get method, remember, works almost the same way as d square bracket x would, except that it gives you the value corresponding to the key x if it exists. If not, it gives you the default, and the default is none by default, but you don't want that. What you want is this. So try to understand what this is doing. What this is doing here is this. It's trying to get the value corresponding to the key x. If it is there, fine. Whatever number is there, you're going to add 1 to it, put it back to d square bracket x. So the count which you're maintaining in d square bracket x, that gets updated. That works fine. But if it is not there, it's not going to raise a key error. It's going to return the second argument. And the second argument here is given is 0. It's going to just return 0. And that's reasonable. If you're going to fail to find x in your dictionary, that means the key is not yet there. So the count is 0 as of yet. Adds 1 to it. Returns 1 to d square bracket x. This is the first time you have met that. And it works fine. At least no errors. Let's just check what D has now. Well, now D has all these words, something like asymmetrical, 1, that means they're only once. Chemistry, comma, is there twice. As I said, this is not very, as yet, very precise, it's rather crude. So chemistry and chemistry, comma are treated as different words. That's why the count is that small. But let's see, urinary is there twice and so on. And we can even try finding in, right? We found that is there several times, 33 times to be precise. So I have now got a dictionary which has all the words in my original string along with the counts. But you would agree that this is fine, but I have achieved my task. But isn't there a better way to present the final result? And we are going to come to that soon. But before that, let me show you another cute way in which you can actually do the same task without resorting to the get method. Essentially trying to do dx plus equal to 1. But wait a minute. Didn't I say right now that that's going to lead to an error? And it will. So how do we get around that? This actually will illustrate a rather important thing in Python programming. This is not there only in Python programming. This is there in many other programming languages. It's called exception handling. If you know beforehand that doing something is going to raise an exception, which is a fancy way of saying there will be an error if you do something, then very often you can actually write your program in such a way that it not only prevents a problem due to the exception, it actually uses the exception to do whatever you want to do. So let's try to show you how that works. Let me go back to the empty dictionary first, and then just to remind you what we are trying to do, there's this list we have called L, which has many words, and what I tried and failed to do was this, d square bracket x plus equal to 1. Remember, we already explained why there was a problem doing this the first time around. That's simply because the keyword, in this case the keyword the very first keyword, was not there in the dictionary D as yet. The dictionary D is empty. So you got a key error. Now, how do you handle this? Well, you handle this using something called the try except block in Python. So this is exception handling, a rather advanced topic, but at the same time simple enough to use and cute enough to be something that's worth learning. So what we do is for x in L, and then instead of doing this, which will give me an error, I say this. So I'm asking Python to try to do this, and try is a header line of a compound statement, as you can see with the colon. So to tab dx plus equal to 1 further in. So what you are saying is, try to do this. And except. So try to do this. If there's an exception, if Python sort of talks back to you and says, no, you have made an error here, then you can use the except block. So you try to do this. If it fails, you go to the except block. And you can actually be more precise. You can even specify exactly what exception you're looking at. We know that the exception that we will get here is key error. So let's put that in. Except key error. So except if there is a key error, what will you do? You know that you messed up because you tried to find the value of something which was not in the dictionary yet. So what you will do is you will assign a value to that now. What value will you assign? Remember, here you have already found the very first occurrence of the thing. So now what you need to do is dx, just assign 1. There's a slight difference between this and using the get method that we talked about before. Because when you were using the get method, you were adding 1 to the result anyway. So you have to return 0. So that adding 1 gave you 1. Here, of course, there's no addition of 1 in this case because that was in the try block. You failed there, and that's why you have come to the except block. So just assign dx equal to 1. So what does this do? It sees whether the key is there in the dictionary. If it is there, adds 1 to the count. If it's not there, that means you have found your first occurrence of that particular key. You assign 1 to the count for that particular key, and you're done. So this is your D. And if you had a wonderful memory, you would be able to remember that what you have here is exactly the same dictionary as the one we had before. Just to convince you, let's try to figure out what is the value for in, which we did check earlier. It was 33, remember? Let's see. It's 33 again now. That of course is not really a check that the two dictionaries are identical. You would really have to go through all of the elements. But this is a good enough check, I would guess. If you've understood the logic that we used here, you should be convinced that both ways we will end up with the same final dictionary. Keyword values. Keywords are just the words in my string. Values are just how many times they have occurred. But now comes the issue of presenting these in a nice manner. One thing we could always do is, well, you could look at all the keys that are there in the dictionary and then print the dictionary values one key at a time. So keys is a method, remember, which extracts from the dictionary all the keys it has. That's an set-like object, but it's an iterator. It comes in pieces. So all I'm saying is, take each key in d.keys, that's a k, and then print the value. Print both the k, which is the key, and sorry, not a semicolon, but a quote here, that's what I meant. Put a tab, maybe 2 tabs to space out the thing properly, and then put D square bracket key. So you're printing the key and the value corresponding to the key with 2 tabs in between. Yeah. Notice that because some of the words were actually longer than a given tab stop, these have been pushed further. So the formatting has not been that great. We can make it better by using various string methods, but we will look at that later. One advantage of this, which may not be very obvious right now, is that say something which occurs 4 times first has not been printed out 4 times, as was the case in our very first attempt. It has only been printed once, because your dictionary has only one key first, and the value 4 just says how many times it occurred. Good, but wouldn't it be better even if we could order it somehow? And let's say order it in the order in which the values are. I would love to see, say I might even love to drop all these words which are occurring only once and see only words which are occurring, say, more than 5 times. Now that one is easy if we don't worry about the order right now. Could just say something like this: if D square bracket, there's a new keyword that I'm using, so I'm a bit unsure about where all the keys are right now. If dk is bigger than 5, let's say, only then do we print this, and since this is inside a compound statement, I have to tab it in further. Then now I'm going to get a much smaller list, and see, the of course occurs very many times, 81 times, and so on. So this is one way, still not sorted properly, but a much smaller view, which is definitely fine. This is something which you could do only because the counts are there in your dictionary. If you had just printed out all the counts with word values, the ones we tried first, you would not be able to do this. You could of course say every time L.count x exceeds 5, we are going to print the value, but then this the would have been printed 81 times. The 81 would have been printed 81 times. Still not there yet, because we have not yet managed to sort the thing properly. I would love to have this sorted in, say, the order of occurrence. And I would have also loved the appearance of the output to be better, say, without these jagged ends and so on. To do all this, we will have to wait till the next video, where we will learn a bit more about string handling, some more tricks with lists, and couple them with the dictionary methods that we have learned so far, to the end that we will finally end up with a much better looking final answer, the kind that we want. You should realize that even with the very few methods that we have learned so far, we can actually do quite nice and useful programming tasks. More on that in the next video.